Welcome back to the video lecture series for Introduction to Data Programming using Scala. In this video we continue talking about stream I/O, and we're going to continue looking at exceptions, and in particular look at something called the lone pattern. So in the last video we saw how we can use try, catch, finally to basically do proper error handling for our simple example of opening a file and reading its contents. And what we saw was that it made the program significantly larger. And this is in some ways problematic because if you have to go through this much effort to do proper error handling for even such a small example, it turns out that most developers, probably including you, won't bother to do it a lot of times, or you'll leave something out, or you won't do it quite right. And that can be disastrous for an application. So we want to have a way of making it so that we can do what we've done here, but do it in a way that's a little bit easier for us to write. And the main thing that I kind of want to eliminate here is the need for the nested try statements. Okay? I don't want to have to nest one try inside of the other. And of course the reason we had to do this is because we needed this finally with the close. We needed to make sure that if the file had appropriately opened, that we would close it here. But then we wind up with cases in two different places that really are doing almost the same thing. And so we want to try to get rid of this. One thing that's worth noting, since I mentioned the two cases in different places, we've written lots of code that can throw exceptions, and we haven't put in try-catch in most situations. And so the question is, well, where should you, when you're developing programs, where should you put a try and a catch? Where should you have cases for dealing with exceptions? And the answer to that is you put those in the code that knows how to deal with them. Okay. Library code that is going to be performing some I/O for you generally doesn't know how to handle it if something goes wrong. Okay, if you pass them an improper file, or if the file has the improper contents, the library code generally doesn't know the right thing to do. So it generally does not catch its exceptions. It just allows them to propagate up the chain until you get to a higher level method that should know how to deal with that error. So back to the lone pattern. How do I get rid of this doubly nesting? Well, I'm going to write a method in here. Now in a real application, the idea here is you get to write this once. We're going to write a method of I'm going to call it do with file. How about it just called do with file input? Except I can't type input. Okay. And so what I want to do, so first off, we might need to return a value. So I'm going to make this so it has a generic for the type to return. And then I want to pass in the name of the file that we want to work with as a string. And I'm going to curry these arguments. I'm going to give two arguments here, and you'll see why syntactically that makes sense. After that, I want to have what we want to do with that file. And so I will refer to this as the body. And so this gets passed in body is going to be a function that we call by passing it a file input stream, and it's supposed to return to us the type A. This whole thing returns to us type A, and we can write the function. So what do I know is going to go inside of here? Well, I need to do basically two things. I need to open the file. So we'll do a val file input stream around the file name. I could also have a version that takes a file instead of a file name. And then I'm supposed to execute the body on that file name. Now, the thing here is this doesn't do anything with error handling. This is the basic functionality that we need. But now I want to put in the code that really has that finally clause. I want to make it so that if something goes wrong here, I will always close the file. Okay. So this is just a little helper function, and it makes sure that when this is done, it's supposed to do whatever the body function was going to do, but it makes sure that it closes the file. And that means that when we come back to here, if I want to do this same example, but I want to use the do with input file, I'm going to change things up. Do with input file. Note that I kept the outer try here. File dot get absolute path. Sure. That will give me the long full name of the file. And then the reason I curried this is because what comes after this is actually going to be fairly long. Now, of course, inside of here, we open the file, so I can get rid of that line of code. What do I want to do? Well, I want to open a buffer, I want to read the buffer, and I want to print out the buffer. And what are we unhappy? Okay, well, I'll continue editing this. And then I'll put that one case inside of here. So let's see, what are we unhappy with? Do with, I believe that was file input, not input file. Okay, and the second argument to this should be a function and there we go. Okay, so our do with file input, we pass it the file that we want to work with, and then we pass it a function that takes the file input stream and uses it however it wants. Note it does not close it here, because this is supposed to be responsible for opening and closing, and then it delegates only the actual activity to the body, and that's what we've passed in here. This also makes it so that all of the exceptions that we might need to handle and inform the user about are then here inside of a single catch. So this code is significantly easier to read than what we had before with the doubly nested tries. And once again, the idea is that this would not appear in every single file. This would appear exactly once, so that we could call things in this way repeatedly instead. And we'd be guaranteed to have the proper safety of it closing the files and whatnot. So that's it for this video. In the next video, we're going to come back and we're going to look at how we can get a little bit more functionality out of our streams by using something